Okay, we're going to look at the sine rule today, but before we do that, we've got to look at how we label non-right-angled triangles. So far we've been looking at right-angled triangles, and they're pretty easy to label because you've got, your right angle, and hence you can work out, that the hypotenuse is always opposite your right angle, all that kind of thing. So they're pretty easy to label, but non-right-angled triangles are a bit hard. So what we do is we have a system to do it, and this is it. All you do is each angle, you name it the same as the capital letter that is the same as the vertex. So here we've got vertex A as in like the corner A, its angle is A in here. Yeah. Opposite the angle A is side length little a, and then so on and so forth. So opposite C is little c. Angle big C is side length little c. So if I just make another one, so say I've got my non-right angle triangle, this one, PQR. So each of the angles, right? So that is angle Q, for example, right? And that means opposite it is going to be little q. Opposite R, little r. Opposite P, little p. It's a bit hard to tell that that's a little p and that's a big P, but there we go. So if we go on, so now we know how to label them, great. What we want to do is look at the sine rule and see how we're going to use it. So here is the sine. It relates side lengths on the top here with the sine of their angles on the bottom. And so they're all just these little fractions. And perhaps you can see that if I were to take the reciprocal of both sides of that equation, I could get something that looks like very similar, right? Sine of A on A is equal to sine of B on B is equal to sine of C on C. So depending on what we want to solve for, you could do it so that you've got the sine of the angles on top or the side lengths on top, but those are equivalent statements, right? Now, the times that we do it is if we're given one side and two angles, or if we're given two sides and an angle other than the one in between them. So say I knew the length of C and the length of B and the size of this angle A. Because that's between them, I can't actually use the sine rule for that one. We're going to need a different rule that we're going to learn down the track. So in terms of these times to know when to use them, frankly, I don't actually remember these things. When you get into using these things, it'll just start to be, you'll look at it and go, oh yeah, well I know this and this, maybe I could try using the sine rule. And it's just a matter of practice really. But if you wanted to have, hard and fast rules of when you can use this rule, here they are. Okay, I'm going to prove it to you just here. So if we look at this triangle, and we've got it all nice and labeled, well, it's pretty hard to prove it without putting in another line because this doesn't have any right angles. And in terms of our trigonometry, most of the knowledge we've got is to do with right angle triangles. So I'm going to create some right angle triangles by just drawing in a vertical line here, dropping down from B, and we're going to call it H for height. So what we can do now is we've got H, and all we're going to do is we're going to find the value of H in terms of various little things. Seeing as we've got one right angle triangle here with that right angle, and then I just change color. We've got another right angle in here. So we've got two right angle triangles, and we just need to find H. So let's do it. First of all, so let's do sine of A. Sine of A is opposite over hypotenuse. So the opposite is H in this case, and the hypotenuse is C. Now let's rearrange for H. So H is C sine of A. Now we also want to, let's get H in terms of this, the sine of C. So I know the sine of C is opposite over hypotenuse. For this right angle triangle with the pinkish right angle drawn in, the opposite is H, opposite to this angle here, and the hypotenuse is A, opposite to the right angle. So rearrange that for H, and I get just times both sides by A. H is sine of C. Now we can see we've got something in terms of h, something, or h equals this, h equals that, so they must be the same, right? So c sine of a is equal to a sine of c. Now I'm just going to divide both sides by a, so I get c sine of a on a is equal to sine of c. And now divide both sides by c. I'm just going to write it up here. So sine of a on a is equal to sine of c on c. Now this looks a lot like my rule, my sine rule, and I can just show you it back on an earlier slide. Oh, it's a bit messy, but you can see it's very similar. I haven't got the b sine of b bit. If I wanted to get that, I would just have to drop in a different vertical, and I could do that. So that is it. And what I'll do is, if you want to see it in pretty latex beauty, you could pause the video here, have a read through of this. It's a bit prettier, and it tells you about how to get the next one. And